Welcome to the Science and Technology Current Affair class. Today we will be discussing two important current affairs topic from science and technology. The development happened in this year 2024. So we will be talking about two topics. Number one will be hypersonic missile test, and number two very famous, that is mission Chandrayaan 3. Hypersonic missile test done by DRDO, Defense Research Development Organization, and Chandrayaan 3 by ISRO, Indian Space Research Organization. Let's first take hypersonic missile test by DRDO. So we will be discussing hypersonic missile test by DRDO. Let's first understand what is missile, what is hypersonic, and then we will go into the details of this topic, right? So what is missile? When we talk about missile, missile is a type of weapon. Missiles are a type of weapon that can be launched or thrown at a target, right? They are guided by a system such as a radar or infrared sensors to ensure they hit the target, they hit their targets, right? Okay, so basically there are majorly broadly two types of missiles. Number one is guided missiles. They are equipped with guidance system that allows them to hit their target, right? And they can be, so they are guided missiles means they are having guidance system, and they are having a guidance system and they can be launched from various platforms. So launching platforms can be various means such as aircraft, ships, or land based launches, right? Whereas when we talk about other type, that is ballistic missiles works on ballistic trajectory. Ballistic trajectory means they are launched into space and then they fall back to earth. They fall back to earth under the influence of gravity. So these are some basics of missiles that we wanted to understand first. This is missile, and then now we can understand what is hypersonic missile. Let's understand what is hypersonic missiles. So the classification of missiles on the basis of their speed is known there is also one of the classification of missiles on the basis of their speed, and one of the missile that we can have is hypersonic missile, subsonic missile, supersonic missiles. These are the types. So these are the classification on the basis of their traveling speed, right? So basically we compare the speed of missile with the speed of sound, with the speed of sound, and that we call Mach, right? So subsonic means below 1 Mach, right? Below 1 Mach, zero point 0.7 Mach, zero point 0.6 Mach will be subsonic. Supersonic will be greater than that. So hypersonic is having speed of sound is Mach. So hypersonic speed is more than hypersonic speed is more than 5 Mach, more than 5 Mach, 5 Mach or Mach 5, right? This will be the speed of 5 Mach means 5 times the speed of sound, right? So that is why it is known as hypersonic missiles. Now let's understand what development has happened, why we need to study this topic. So now we want to understand the recent development or the news maybe, right? So the recent development that has happened. Recent development is about DRDO has successfully tested long range hypersonic missile off the coast of Odisha on November 17, 2024, right? Now we have understood. So one more there was one more incident when these hypersonic missiles were in news, that when Russia has also deployed hypersonic missiles in Ukraine war. So in Ukraine, because it was in news that it destroyed a large underground ammunition warehouse, large underground ammunition warehouse in 2022. So it made news at that time also, but recently it is in news with respect to Indian context, that is the testing of DRDO, right? Let's understand some features of recent this hypersonic missile test. Features of hypersonic missile test by India. So let's understand what are the features. So number one, when we talk about its range is more than 1500 kilometer, more than 1500 kilometers. Its speed, as we have already talked about, more than 5 Mach, so approximately 6 Mach, approximately 6 Mach, somewhere around 6120 kilometer per hour, right? And it has mid-flight maneuverability, means it can be maneuvered during mid-flight, right? So mid-flight maneuverability, and it is having advanced tracking system, so that it does not miss its target, right? And it is having multi payload capacity. Payload means its warhead, right? So multi payload capacity. Conventional warheads or nuclear warheads, like both. So conventional warheads, explosions, or maybe explosives or something like that. So conventional warheads or nuclear warheads as well. Fine. So these are some of the features of it. Now, what are the significance of this development? What are the significance of this development? So some significance we can talk about here is it is indigenously developed, right? So indigenously developed by DRDO. Number two, it places India with several, or with among it places India among a select group of nations which are having this technology. Select group of nations which are having this technology. For example, US, Russia, and China. Right? It enhances our defense capabilities. Enhances India's defense capabilities. Right? So these are some of the significance of this development that has happened recently. So this is what we had to discuss about hypersonic missile test. Now we can move further to discuss about Chandrayaan 3. So let's understand Chandrayaan 3 mission. It was in news, and there was lot of celebration with respect to Chandrayaan 3, because we had little bad experience with respect to Chandrayaan 2. Our lander crashed during the soft landing, right? So let's try to understand the Chandrayaan 3 mission, some specifications of it. So first, some information about the recent development, means about the launching date, etc. Recent developments about Chandrayaan 3. So Indian Space Research Organization ISRO launched Chandrayaan 3 by using geosynchronous satellite launch vehicle Mark 3. Satellite launch vehicle, these are generations: Mark 1, Mark 2, Mark 3, also known as LVM 3. Satellite launch vehicle, geosynchronous satellite launch vehicle Mark 3, also known as LVM 3, on 14th July 2023 from Sriharikota. Right? Chandrayaan 3 carrying the Vikram lander and Pragyan rover. We will try to understand what is lander and rover. Pragyan rover made the historic soft landing on the surface of the lunar south pole. The lunar south pole on August 2023. August 23, 2023. Right? So, why it took so much time, and what is lander rover? Let's try to understand. So, basically, we follow. This was the recent development that has happened. Now, when we talk about features of it, let's first understand features. So, this follows low energy transfer method. India follows low energy transfer method, as we saw in case of many other missions also. Example, in case of Mangalyaan, Mars orbiter mission also, low energy transfer method we followed. What is low energy transfer method is, this is Earth, and this is, for example, in this Chandrayaan case, it is Moon, right? So when we launch our mission, or this launch vehicle, this launch vehicle will not directly go to the moon like this will not take a flight. Rather, what will happen is, it will be launched into earth centric orbit, and it will orbit mission, and it will orbit Earth, and it will be given thrust at some point of time, and it will, when it will be in the lunar centric orbit, when it comes into the lunar centric orbit, this is the transition. This transition will happen only when the satellite or the payload, or when the satellite will be in lunar centric orbit. So when it is in lunar centric orbit, now it will maneuver here, and then it will land to the moon like this. This is low energy, means the fuel requirements are less, and the mission cost decreases to a great extent. So like this we take. Otherwise, a simple flight can be taken, right, like this. I will show you the diagram. This is the journey to moon. So you can see, it was launched in first earth centric orbit, so it was maneuvering around the earth only, and then it got transferred into lunar orbit, right? It got transferred into the lunar orbit, and then it was orbiting the moon, and then finally it landed over moon, right? And why this development is very important, because you can see here, this is the moon, right? And this is Chandrayaan 3, marked in this yellow, you can see here. This is Chandrayaan 3, right? Where the Chandrayaan 3, or whether lander uh, landed on the surface of moon. Otherwise, you can see that other missions, these are scattered here in the mainly in the northern hemisphere. But you will see it is south pole of the uh, Chandrayaan, and very near to that there is recent Russian crash that has happened, right? So why South Pole is so important? Because the it is very much less visible to the sun, so you can find some ice type molecules there, so which will help in the discovery of water, right? So you might be remembering about the Chandrayaan 1 mission, where we found ice crystals, etc. So it is there to uh, do research, etc., right? So this was low energy transfer method. It was the first point of the feature, right? And it was the second attempt. The first attempt, as we are aware, was Chandrayaan 1. Chandrayaan 2 was the first attempt to do soft landing, right? So this was Chandrayaan 3, second successful, but it was successful mission. And India became the first nation to soft land on the South Pole, right? This we have understood. Now let's understand the payloads, means what devices are there in rover, in lander, right? So let's understand payloads. So we can understand, yes, we can understand payloads like this. First, we will try to understand lander payloads. What are there with landers? So let's first understand what is lander and what is rover. So this is the surface of moon. For example, the mission landed here. So this is the lander which will land, and the robot will come out from this lander, and this can roam, and this can move on the surface of moon. So this is known as what? Rover. So which can move on the surface of moon, is it is lower, and the static body will be the lander. Static body will be the lander, moving body will be the rover, right? So what is lander and what is rover? I guess we are clear with this. So let's understand some payloads. What was there, what things were attached to lander, what things were attached to rover. So with lander we were having one device known as Rambha. So what is Rambha? Radio anatomy of moon bound hypersonic, moon bound hypersensitive, moon bound hypersensitive ionosphere and atmosphere. This is Rambha. This is to measure the plasma density function near the lunar surface. So we can remember like this: to measure plasma density function near the lunar surface. Second device that was attached with the lander is also known as Chaste. So what is this exactly? Chandra's surface thermophysical experiment. Thermophysical experiment. This is to carry out thermal traits, temperature variations, etc. of the moon's frigid polar zone. Right? There is other instrument attached to it, also known as ILSA. What exactly it is instrument for lunar seismic activity. This is to measure seismic activity, unveiling lunar crust mantle configuration. Like in physical geography, we understand about S waves, secondary waves, primary waves, S waves, and P waves to understand crust and mantle and the depth of the Earth's surface. Like that, crust mantle configuration of the moon surface, right? So this was the third device that was attached with the lander. Also, that was one more device that was attached with lander that we can write here. LRA, laser retroreflector array. It was to understand the dynamics of moon system. Right? And there were few payloads attached with rover. So rover payloads. There was one APXS, alpha particle X-ray, X-ray spectrometer. It is to determine the soil and rocks chemical composition and mineral attributes, because rover will move on the surface of moon surface, so composition and mineral attributes, right? One more thing was attached to it, that is the second one, LIBS. This is laser induced breakdown spectroscope. This is to analyze elemental constitution, element constitution, elemental constitution, which will help in lunar geology insights, right? So these were the payloads with rover and lander. One more thing we have to understand here is this was a kind of failure based design. The difference between Chandrayaan 2 from Chandrayaan 2 to Chandrayaan 3, it was failure based design. Chandrayaan 3 failure based design from success based. So we can like this, from success based design to failure based design. What do we mean by this? Even if all sensors, engines, everything fails, then also the Vikram lander should have landed, lander Vikram should have landed softly on the surface of moon, right? So this was all about Chandrayaan 3 mission. I hope we have understood these two topics properly. Let's see in the we'll meet in the next class. Take care. Bye bye.